Hey guys, StatsGuru here, and in today's video, let's look at finding some probabilities under the standard normal curve using the standard normal table. So to do that, I've written down 3 tips that we typically want to think about when using the standard normal curve, and it will help us find our probabilities, and it will also help with some of the problems that we're going to look at. So one thing to know is that the total area under the curve is equal to 1. So if we look at the curve down below, we know that on the left and on the right hand side of the center is a total area of 1 or 100%, meaning that there's a 100% probability underneath the curve. Number 2 is that the curve is symmetrical. So any probability we find on the left hand side or we find on the right hand side would be equal to one another. And the third point is just something to remember. The center of the curve is in fact 0. So when looking at the standard normal table, which we'll get to, the center is at 0 and we move from that point. So in this first example, let's find the probability that z is less than negative 2.53. So what I like to do is I typically like to draw out our curve to see where our critical value is and then go from there on the standard normal table. So as we draw our curve here, the center is at 0, and we're looking at negative 2.53. And we want to know the probability that z is less than negative 2.53. So we want everything to the left. So let's go ahead and look at the standard normal table. So here we have the negative side of the standard normal table, and we want to find our value of negative 2.53. So we're going to go ahead and go down to negative 2.5 and then work our way across to 0.03. Then we're going to go over, we're going to come on down, and we see 0.0057. So the probability that z is less than negative 2.53 is equal to 0.0057, because that's everything to the left-hand side. How the standard normal table works, if we were to think about the standard normal table generically, typically it's whatever value we have and it's all the probability up until that value. So everything to the left of it. So that's how we can think about using the standard normal table. For this example, we want to find the probability that z is greater than negative 1.46. So let's go ahead and draw out our standard normal curve. We have our value of negative 1.46, and we want to find the probability of everything to the right hand side or greater than this value. So how do we do that? Well, we have to think about one of the tips that we talked about in the beginning, that the total area under our curve is equal to 1. So if we know that the total area is equal to 1, we can then take 1 minus the value that's less than our critical value, which would give us everything in between to the right. So let's go ahead and write that down. So the way that we find this is we're going to have 1 minus the probability that z is less than negative 1.46. And that's going to give us this blue region. So that's going to give us everything in between. So let's go ahead and look at the standard normal table to find this probability. So again, we have the negative side, so we're going to go all the way down to 1.4, and then we're going to go over to 0.6. So when we go over, we go down, we see that it's 0.0721, and we're going to leave it at that. So we're going to have 1 minus 0.0721, which gives us a value of 0.92, so 0.9279. And that would be to the right hand side, or the probability that z is greater than negative 1.46. Let's look at another example here. Let's find the probability that z is greater than 1.12. So again, let's just go ahead and quickly draw our curve. We have our value of 1.12. We want to find everything to the right hand side, or greater than 1.12. So how do we do this? What we'll do is we go back to that tip where we take 1 and then we're going to minus everything to the left of our value. So everything less than this, which will give us the area we need. So if we write this down, it's going to be 1 minus the probability that z is less than 1.12. So let's go ahead and jump over to the table to figure out what this value is. So here we have the positive side of the standard normal table, and our value is 1.12. So we are going to go down to 1.1, and then we're going to go over to the 0.02. And this gives us a value of 0.8686. So in our equation, we're going to have 1 minus 0.8686, and that gives us a value of 0.1314. Now to show you the power of this curve and how symmetrical it is, let's find the probability that z is less than negative 1.12. So if we draw this out, we're at 0, and our value is negative 1.12, and we're looking for everything to the left-hand side. Let's see what we get. So we can just jump right on over to the negative standard normal table. So here we have the negative standard normal table, and we're going to go down to negative 1.1, and up here we're going to go to the 2, and then we're going to go over and down. And lo and behold, we get 0.13136, but if we round up, we get 0.1314. So the probability that z is less than negative 1.12 is the same as before. It's 0.1314. So whether we have probabilities on the left, or if we had a positive 1.12 and we were looking for probability on the right, these would be the exact same answer. For this next example, let's find the probability that z is less than 1.87. So let's go ahead and draw our standard normal curve. We have 1.87. We're going to find everything that is less than that value. So let's go ahead and jump over to our positive side of the standard normal table. So here we have the positive side of the standard normal table, and our value is 1.87. So we're going to go down to 1.8, and we're going to go over to 0.07. And we're going to go ahead and go over. We're going to go ahead and go down, and we see that we get 0.9693. So the probability that z is less than 1.87, that's equal to 0.9693. Let's look at another example where we want to find the probability that z is greater than 2.44. So let me just draw out the curve here quick. And we have a value of 2.44. Again, so how do we find something that's greater than? Well, we have to remember our tip that the total area under the curve is equal to 1. So we're going to have everything, and then we're going to subtract everything less than our critical value. So if you write it out, it's going to be 1 minus the probability that z is less than 2.44, and that will give us the area that we are looking for in between. So let's find what the probability that z is less than 2.44 is. So here we have the table, so we're going to go down to 2.4, and then we're going to go over to 0.04, and we end up with a value of 0.9927. So we're going to take 1 minus 0.9927. We end up with 0.0073. So that's our probability that z is greater than 2.44. So what if we have an example where we want to find the probability between two critical values? In this case, 1.14 is less than z, which is less than 2.31. Let's go ahead and walk through how to do this. So for the starters, let's go ahead and just draw the curve, because it will help us visualize what we're looking at. So we're looking at the value between 2.31 and 1.14. So the area of interest is between these two values. So how do you think we would calculate this? Let's think for a second. And you may know the answer. But what we're going to do is we're going to take the value on the right and we're going to find everything to the left of that. And then our second value, or our lower value, we're going to find everything to the left of that. And if we subtract these two or find the difference, we will then have our area of interest. So to solve this problem, we're going to have the probability that z is less than 2.31, and we are going to subtract the probability that z is less than 1.14. And this will give us the area in between our two critical values. So let's go to the tables and find 2.31 and 1.14. So for the first value, we have 2.31. So we're going to go down to 2.3, go over to 0.01, and we end up with 0.9896. For the second value, we have 1.14, so we're going to go down to 1.1, we're going to go over to the 0.04, and we find 0.8729. So now we just plug these into this little formula here and we'll find our answer. So we're going to have 0.9896. We're going to subtract 0.8729. And that gives us a value of 0.1167. So the probability that z is greater than 1.14 but less than 2.31 is equal to 0.1167. Let's do another example between two critical values and see what we get. So for this example, let's find the probability that z is between negative 1.04 and 0.76. So again, I would just draw out the curve quick. So we want to find the area between 0.76 and negative 1.04. So we're interested in everything in between. Just like last time, we're going to take everything that's lower than our top value, and we're going to subtract everything that's lower than our bottom value, and that's going to give us the area of interest. So if we write this out, it's going to be the probability that z is less than 0.76. We're going to subtract the probability that z is less than negative 1.04. So let's go ahead and find these on the table and then finish the problem. So our first value is 0.76. We're going to go down to 0.7. We're going to go over to 6. And as we go over and down, we find 0.7764. Our other value is actually on the negative side of the table. So here we want to find -1. So -1.04. And we're going to go over, we're going to go down, and we see that we get 0.1492 if we round up. So in our equation, we're going to have 0.7764, and we're going to subtract 0.1492. That will give us the answer of 0.6272. So the area that, or the probability that z is greater than negative 1.04 and less than 0.76 is 0.6272 or 62.72%. So there you have it, guys, just finding some areas under the standard normal curve using the standard normal table. I hope that this video was easy to follow along with, and I hope that it helps you with your statistics. As always, feel free to comment down below any video topics or ideas that you would want some help with. I'm more than happy to make a video for you. Make sure to like and subscribe, and as always, we'll see you in the next video.